6.6. Yes, this does appear on your test. It's not like the most important concept we've ever learned, but they love, love, love to put these problems on the ACT. You'll probably see one similar to the ones on this page, one similar to the ones on the next page. They love these problems. And they're interesting. They're like fun algebra problems. So let's take a look here at 6.6 placing figures in the coordinate plane. Essentially what this is geometry properties, but filling in those equations, those properties, with a lot of things that aren't like solid numbers. They have letters in them, so it's like algebraic manipulation. It's not too terrible. And number one, it says find the midpoint of AC. Do we remember what the midpoint, like how to find the midpoint between 2 points is? Maybe not. The midpoint is the average of the x's and the average of the y's. So if I'm looking here at AC, W represents the midpoint, and I need to find the coordinate value of W. So what I'm going to do is I'm going to look at the two endpoints of this line, A and C, and I'm going to average out the x and y values. So x, I'm going to represent in red, y, I'm going to represent in blue. So for the x's, the average of my x's, which is going to get me the x value of point W, is going to be 2a plus 2c over 2. That's how I find the average of something, right? Now, the hard part for us is not setting this up necessarily because these are formulas that we should be familiar with. The hardest part is going to be simplifying them. So in this case, to simplify, I can cancel out those 2's. This just becomes a plus c. That's as far as we can simplify that. And I'm not going to try to go any further. That is going to be the x value of my coordinate. And it looks weird because it's not a number, but that's it. Then I do the same thing for my y's. So for y's, I want 2b plus 2d over 2. And again, I can cancel out those 2's. The y coordinate for W is b plus d. So literally, as a coordinate point, W is a plus c, b plus d. Any questions on that? That's as far as I can simplify that. So the formula isn't necessarily the difficult part because we should know that formula. The difficult part is like the simplifying and the accepting defeat that as far as we can simplify is b plus d. Okay, so then we get a little bit trickier when our formulas get a little tiny bit more complicated, but they're not going to be too complicated. These are all formulas we've seen before. So number 2 says find the length of WV. Here's WV. Do we remember how we find length in a coordinate plane? How we've been doing it in all of those quadrilaterals we did? Yeah, Caitlin? Pythagorean theorem. We're going to use the Pythagorean theorem. Instead of like a squared plus b squared equals c squared, what I'm going to do, I'm going to draw a little thought bubble down here so that we can see. Imagine this is like our coordinate plane, right? If I was trying to find the length between 2 points, let's call this one 4, 9, and let's call this one, what did I say? 7, 5. If I wanted to figure out the length in my Pythagorean theorem right triangle without like counting boxes because I don't have boxes to count, I would be doing the change in the x values, which is down here, is equal to 7 minus 4, right? I take the bigger number, which is on the right. I subtract the smaller number, which is on the left for my x values. I would do the same thing for the y values. My change in y is represented by the bigger number, which should be on top, minus the smaller number, which is on bottom. So those side lengths of that right triangle, even though I can't count the boxes, I can figure out that those side lengths are 3 and 4, right? That's how we're doing that. I'm going to do that same exact thing, but I don't have numbers. I have abstract values here. It's going to look a little bit silly. But we are thinking about the length of WV squared is equal to the change in my x values squared plus the change in my y values squared. So, starting with the x values, I'm going to highlight, here are my x values, a plus c and c plus e. I want the bigger one. If I'm thinking about a number line, the bigger one is always on the right. So I want c plus e minus the smaller one, a plus c. When I plug this in, it is very, very important that we are putting this in parentheses because I want to subtract that entire thing. That's going to end up distributing that negative sign to the a and to the c. So we don't want to forget it. That's the first part, change in the x's. Then I'm going to do change in the y's. So plus the change in the y squared. Now I'm going to start at the top because that's where my biggest y value is and subtract the y value on bottom. So this is b plus d minus d squared. And that's my formula. That's plugged in. That's my Pythagorean theorem. From here, all I got to do is simplify. So I know that I can distribute this negative sign, okay, to get c plus e minus a minus c. That's going to cancel out some c's for me. So left in these parentheses, I have e minus a. And then on the other side, the d's are going to cancel out. So I just have b squared. We good there? I'm almost done. I want WV by itself. To get rid of the square above the WV, I'm going to square root both sides. Okay? Now, pay attention to this, because if you think about the Pythagorean theorem, if I have, I'm going to write it like this. I'm going to write it off to the side. If I have c squared equals 3 squared plus 4 squared, have we ever, in the history of when we are doing math, just square rooted this and canceled out all these squares and said, well, c is 3 plus 4? Have we ever done that? No. So we are not going to do that here. I'm going to say WV equals the square root of e minus a squared plus b squared, because those squares can't just cancel each other out. I never did it before with the Pythagorean theorem. I never did c squared equals 3 squared plus 4 squared, c equals 3 plus 4. So I'm not going to do it here. This is literally as simplified as this gets. I'm done. Any questions on that? Okay. One more like this. This one is the slope of WV. Do we remember our slope formula? M equals, anybody? Y2 minus Y1 over X2 minus X1. That's my slope formula. Guess what? I have X and Y. X1, Y1, X2, Y2. It does not matter which one we pick to be X1, Y1, as long as we pick the same one. So X1 goes with Y1. Hello? There we go. And it's just plugging into this formula. The most important thing that we remember here is when I plug in, for example, when I plug in Y2 minus Y1, I have to put Y1 in parentheses. B plus D has to go in parentheses because I'm going to end up distributing that negative symbol to the B and to the D. That's the most important part to remember here. That's the part that we get wrong most often. Same thing with the X's. A plus C minus, in parentheses, C plus E. Again, that parentheses to remind myself that I'm going to distribute that negative. And then I'm simplifying. Hello? There we go. Then I'm simplifying. So this becomes D minus B minus D over A plus C minus E. Hopefully we can see that this stuff is going to cancel. I'm canceling out the D and the negative D. I'm left with negative B up at the top. I'm canceling out the C and the negative C, so I'm left with A minus E in the bottom. And that's it. That's our slope. Any questions on that? I didn't do anything too crazy, right? We're okay? Okay, fantastic. Flip it over to the other side. I really like this section. It's a little bit different than what we just did. There's no like big formulas. We are going to take a look at these quadrilaterals. They are all quadrilateral properties that we are familiar with, and we are going to fill in the missing coordinates. So all of those coordinates that have question marks, we're going to fill them in, except our coordinate grid is not like standard 1, 2, 3, 4. It's going by like B's, C's, D's, whatever it is. So again, I'm going to color coordinate this so that we remember. The X values are going to take us left and right. I'm not telling you rocket science, right? We know that the Y values take us up and down. So if I'm looking at something like number 1, which is a square, the number 1 thing that I should be looking for is, what are my square properties? What's my like biggest square property? That all 4 sides of a square are congruent, right? So I'm going to mark it. All 4 sides of that square are congruent. Can we tell, based on these coordinates, what the length of one side of my square is? It's not going to be a nice number. It's going to have a letter in it. But what's the length of my square? Think about how coordinates work. What's the length of my square? Caitlin? Yeah. This Y value is telling me how far up this number line I'm going. I'm going up 3b. Which means the length of every side of my square is 3b. Does that make sense what I'm telling you? That means that this point right here, well, I should do this in red because it's an X value. This point right here is going 3b to the left. What's the Y value down at that point I down there? The X value is 3b. The Y value, how far up or down does it go? Nothing. It doesn't go up or down at all. So this point right here is 3b, 0. What about R up at the top there? What's the coordinate at R? It goes up the same amount as this one, so it should also be 3b. And it goes to the right the same amount as this one, so it should also be 3b. Questions? Move on. This rectangle, we are going to assume that it is centered on this coordinate plane. A helpful hint when we're doing problems like this is if you think about the quadrants in a coordinate plane, we know what the sign of every point in that quadrant is going to be. So for example, in the first quadrant, the main quadrant, we have both X and Y are positive. In quadrant 2, X is negative, Y is positive. In quadrant 3, both are negative. And in quadrant 4, X is positive, Y is negative. It's kind of like a little cheat sheet for us as I fill in this rectangle, because then I know what all the signs should be already. So it's a rectangle. I'm assuming that it's centered on the origin. So that means that each of these little pieces is going to be the same length. So let's start with the X's. The X value tells me that this length from side to side is A. So then this length from side to side is also A, because length is always positive, but the coordinate is going to land me at a negative A, because I'm going the opposite direction in my coordinate grid. Same thing with B. This right here is a positive B. This right here should be a positive B. If I now follow that pattern of what the signs should be, I should kind of figure this out, right? This A lines up with my other A, so that's a negative A. This B is going to be a negative B. And over here, our A should be positive, our B should be negative. Any questions on that? Okay. Number 3, parallelogram. This is kind of a weird one. I can tell a couple things right away. L is kind of a freebie. L is on the origin, so I know that this point right here is 0, 0. D is what I'm trying to figure out. I'm going to start with the y values, the up and down, because I think that the y value in this case is a little bit easier. What's the y value? How far up does this shape go? Dahlia? Yeah, it's the same as this guy right here. So if that's C, this is also C. Okay, perfect. Now, in a parallelogram, what's going to help me figure out, oh, hello, is this a race? Okay. We're going to figure out how long are those bases. That's going to help me figure out the x values. I know how long this base is. It's D. It's telling me right here that this is D. So by the property of parallelograms, it says my opposite sides are congruent. This is also going to be D. Am I going to put D comma C as my point for D? No. I have to figure out what is this missing piece right here. Yes, that length is D of my top of the parallelogram, but I also have that little sliver that I got to account for. What's the length of that little purple sliver? How far away from the x-axis is it, Caitlin? Yeah, it's B. So this is B. The length of my parallelogram is D. So the coordinate, the x-coordinate for D is both of these things combined. It is B plus D. Kind of a weird one. Questions on that one? Okay, rhombus properties. Again, we are assuming all of the rhombus properties are true. Are there any freebies that I can get here? No, I don't think so. When I work on a rhombus like this, and it's in this orientation, I'm going to go ahead and draw in my diagonals. What rhombus property do we know about the diagonals? Caitlin? Diagonals are perpendicular. What else do we know about them? The diagonals, it's actually a parallelogram property, I should say. Parallelogram property, Dahlia, is that a hand? No, not. I want the diagonals. The diagonals bisect each other. That means these pieces and these pieces are congruent. So if I'm trying to figure out let's go with the y values first. For T and for L, I need the y values. Well, the y value of A hits here at 6B. If I want to go halfway down, what's the y value of T and L? That's halfway to 6B. Casper? 3B. Oh my goodness. Hello? Go away. And 3B. Okay, perfect. Can we use that same logic for the x values for L and for A? For A, well, it lines up with K at the bottom here. Do we see? K is here. A lines up with K. So this value should be C. What is the x value for L? If A and K are halfway through that shape and L is on the other side, yeah? Yeah, perfect. Okay, we're almost done. Questions on that? I think 5 is kind of a weird one. It's not that bad. Okay, isosceles trapezoid. In an isosceles trapezoid, we know by its definition that these legs here are congruent. Bam. If I know that those legs are congruent, and I also know that these heights are going to be congruent because they're both E, then I've got some congruent triangles here. That's going to tell me that these bottom pieces are also going to be the same. What's the length of this bottom short leg right here? Anybody? Caitlin? It's B. So then this one is also B. Well, let's call it negative B. Why don't we? So that's negative B. The other one is negative B. If this point right here, H, is telling me that that's at negative 5B, then this whole section right here is negative 5B. If I add on a negative B to that, the x value of this point right here should be negative 6B. You see how I got that? Oh, I'm seeing some confused eyes. Negative 5B is this point right here. So that means this entire length from the y-axis to that point is negative 5B. I'm adding on this section right here, which is a negative B. So in total, that's a negative 6B. Does that make sense? Okay, one more. I think there's a couple freebies that we can get here. I can fill in some zeros for sure. Remember, anytime we touch an axis, that's a 0. So for point U, the y value here is a 0. And for C, the y value is a 0 because they're on that axis. And then for N, the x value is a 0 because it's on the y-axis. So the only thing I need to figure out is the x value for C. What's the x value for C? Dahlia? Beautiful. Because in a kite, those two pieces are congruent, so we should have, oh, that did not look like a negative F. We should have two congruent pieces. Okay, any questions?